Okay, today we are going to start talking about the longest factor string, which is really also called the prime factorization. So on page 46 in your text, it says strings of factors are called factorizations. The longest possible factor string for 840 is made up of prime numbers. This factor string is called the prime factorization. We call it a prime factorization because all of the numbers in it are prime. And we don't ever use the 1. So part of this is pretty simple. It should be kind of a review. The other part, we're going to practice how to find other factors from the prime factorization. So there are two ways that we can use to write the prime factorization. One is the long way, showing every number in the thing. The other is using exponents. Okay, and so for example, there are 3 2's in the prime factorization for 840. So we put a small raised 3 as an exponent behind the 2, and we only have to write the 2 once. But what that 3 does is it tells us that there are 3 2's. So that little 3 takes care of all 3 of these, and we only have to write it once. Okay, so this one down here, this 2 to the 3rd power times 5 to the 4th power, so 2 to the 3rd times 5 to the 4th is really saying 2 times 2 times 2 times 5 times 5 times 5 times 5. Okay? Makes sense? Okay. So we're going to move on now. And the answer to this question would be 5,000, by the way. So there's some other stuff in here that we can write. This is called expanded form when we write it out, showing every number. It's called exponential form when we use exponents. Should be pretty easy to remember. We can read exponents like this. If we had a 2 there, we say 3 to the 2nd power or 3 squared. So if we had a square number, for example, 5 times 5 equals 25, we would say 5 squared or 5 to the 2nd power. If we go 5 to the 3rd power with the exponent of 3, we would use the word cubed. So 5 times 5 times 5 equals 5 to the 3rd power, or 5 cubed. And both of these we tend to use the exponent of 2 or squared when we work with area, and we use the exponent of 3 or cubed when we start finding volume. So that's where that's applicable. Anything larger than the 3, 4, 5, 100, we're going to read as 2 to the 4th power or 2 to the power of 4. There is no other word for 4 or more in the exponent other than just saying to the 4th power or to the power of 4. But the 2 we can say squared, and the 3 we'll use the word cubed a lot. All right, so let's go down here and let's practice actually finding some prime factorizations for a couple of numbers. I have 72 and 32, and both of these are even numbers. Okay? So what we're going to do is we are going to start by making a factor tree. Okay? And what we're going to do is we are going to find 2 factors. Okay, take 72 and find 2 factors that would equal 72. When we do that, most often we think of 8 times 9. Because 8 times 9 would equal 72. Now, when we look at this, we see that both 8 and 9 are here, and neither one of them is a prime number. So both of these can be divided up into 2 equal parts. So we're going to make another couple of branches over here on the 8, and what number times another number, not using 1, will equal 8? Well, the factors of 8 are 1, 2, 4, and 8, and we can't use 1, so we can't use 8. So we're going to say that 2 times 4 is 8, and 2 is a prime number, so we're going to circle it. Okay, and we circle it, that way we can see the prime numbers when we go to write out the prime factorization. And we're going to do the same thing with 4. Again, the factors for 4 are 1, 2, and 4. We can't use the 1, so that negates the 4, so we are left with 2 times 2. And again, both of those 2's are prime. Okay? Then we're going to go over here to the 9, and 9 has the factors of 1, 3, and 9. We can't use 1, which means we can't use the 9, so we're left with 3 times 3. Now, 3 is a prime number. We know that because the only factors for 3 are 1 and 3. So we're going to circle both the 3's. So our prime factorization for 72 is going to be 2 times 2 times 2 times 3 times 3. We have 3 2's and 2 3's. Or in exponential form, we would write 2 to the third times 3 to the second. All right. Now this is just one factor for one factor tree for 72. We could also make another one, and we could start with a 2 and say, how many times would 2 divide 72? Well, the answer to that question is 36 times. Okay, 36 times 2 is 72. And then we're going to do the same thing here and use another 2, and 2 times 18 equals 36. And then we do a 2 again, and we're left with 2 times 9. 2 is square, or prime, so we circle it, and then 9, we are left with 3 and 3, and we still get the same thing, but our factor tree will look different. So there's no right or wrong way to doing a factor tree if you are truly using the factors. Again, these should be factors, which are the numbers that we use to multiply to get to that number, not the numbers we use to add. A very common mistake is to start writing down the numbers that will add up to be 72. We are looking for factors. We're using multiplication and division. So let's practice another time with 32. On 32, we can say that it's again even, so we could use a 2 here. 2 is prime, so I'm going to circle it. But what times 2 equals 32? Well, the answer to that question is 16. Okay, 16 is not prime, so it's composite, so we can use another 2, and we are left with 2 times 8. Okay, and then with the 8, we have 2 times 4, and for the 4, we have 2 times 2. So the prime factorization for 32 is going to be 2 times 5, 2 times 2 times 2 times 2, or 2 to the 5th power. Okay, now that's 2 examples of how to find a factor tree, or how to find the prime factorization. Now what we're going to do is take a look at a couple of factors. So I'm going to write the factors for 32 down here. For 32, the factors are 1, 2, 4, 8, 16, and 32. Okay, so let's see. 1 and 32, excluding these, so if I get rid of those, the rest of these, 2, 4, 8, and 16, I can find using the prime factorization. Okay, I can make a 2 because there is a 2 here. Okay, I can make a 4 by simply taking 2 times 2. Okay, so 2 would be 2. The 4 can be shown by taking 2 of the 2's, or 2 times 2. The 8 can be made by multiplying 3. 2 times 2 is 4, times 2 is 8, so 2 times 2 times 2. Okay, or, again, 2 squared and 2 cubed is 8. And the 16 would be 2 to the 4th power. So all of these factors can be found in the prime factorization other than 1. And that's because 1 is neither prime or composite. It's a special number. 1 only has one factor. It only has 1 as its factor. So, all right, if you need some more explanation of that, make sure you can watch the video a couple of times. Again, this lesson starts on page 46. Before coming to class tomorrow, you need to have solved A1, that is on page 47 in your spiral. Thank you.